Welcome students. In today's class, we are going to start about the chapter water, and we need to see that what is water, what are the chemical properties of water, what are the sources, what is the importance and different states of water. So water is the most important commodity because our body is made up of water and we also need water for all of our daily chores and everything. So it is actually very important for our survival and also survival of all the animals and all the plants as well. Now the water can exist in two states. One is the free state and another is the combined state. What is the free state of water? Free state of water includes the ice, the water and the water vapor. That is the three phases of water. And combined state is water when it is present in combination with something. Suppose if we are eating the watermelon, it is a fruit but it is having a lot of water inside it. If we are eating a cucumber, it is also having a lot of water inside it. So the combined state of water means water that is present inside the juicy fruits or vegetables. Now as we know that the chemical formula of water is H2O. So it is made up of two elements, hydrogen and oxygen. They are chemically combined together to form a compound which is the water. Now as we know that H2O, so two atoms of hydrogen are present and one atom of oxygen is present. So the hydrogen and oxygen is combined in 2:1 ratio and the formula is H2O. The sources of water include the well, rain, river, tap water, lake water, stream water. Some of these water are pure water and some of them are impure water. Rainwater is actually the purest form of water, but in some regions where air pollution is very high, there are many gases that are present in the atmosphere like CO2, SO2, NO2, etc. Now when it is raining in those regions, the water in the rainwater will react with these gases that are present in the atmosphere. Suppose there is SO2 present in the atmosphere, so the H2O will react with SO2 to produce H2SO4, which is sulfuric acid. Then the H2O might react with carbon dioxide to produce H2CO3, which is carbonic acid. So all of this acid when mixed with rainwater might come down as the acid rain, which is very harmful for all animals, the human beings and various structures that are present. Just like the marble of the Taj Mahal has been very much destroyed for the acid rain for the very polluted weather of Delhi. Now the river water, lake water, well water, spring water, all of these are the sources from which the water is collected and used for human consumption. Now the sea water is actually the impurest form of water because it is having a lot of NaCl or sodium chloride that is mixed with it and also salts of calcium and magnesium that is also mixed with it. Now we are going to see about the importance of water in our daily life. First is the life processes. So that is our body's functioning in which the water is very important. First, to maintain the fluid balance and salt balance in our body, water is very important. It also acts as muscle fuel. When we are dehydrated, our muscles tend to get sprained or strained. It is also acting as a fatigue buster. So if we are getting very tired easily, very lethargic easily, so we need to drink a lot of water so that the fatigue cannot be there. Blood normalizer. The blood is having 55% of its composition as water. So water is very important for blood as well. It is also acting as a brain booster. Then there are fluids that are present in our joints. That is actually called the synovial fluids. And this fluid or water is actually making the joint work properly. It is also acting as the toxic remover, as we know that the urine is actually combined of water only, and some of the toxic materials that are dissolved in the water and are excreted from our body. So it is also clearing our skin. So it is always said that we need to intake a lot of water to keep our skin healthy. Next, coming the household processes. The household processes include the bathing, cleaning, cooking, and washing. All of these things need water. So water is a very important part of the household. In firefighting, water is involved, and water is used for fire extinguishing purpose. Transportation. The ships, big launches and steamers and boats are used for transportation from one place to another all over the world. So water serves as the way of transportation. Aquatic habitat, that means the water in which the organisms, including the microorganisms, animals and plants live, and that is their home or natural place of living. In industrial use, the water or the speed of water is actually used for hydroelectric power generation, and also in some areas the water steam or water vapor by using of the boiler is also used to generate electricity. In agricultural place, the use of water is in the case of irrigation, so that the crops can be grown properly and the soil can be nourished properly. And also the fertilizers and the pesticides and the weedicides all need a medium to dissolve or to get dissolved, and that medium is nothing but water. So water is having a lot of importance in our daily life, and without water we cannot survive. Next are the three states of water. And what are the three states? As we know, that is solid, liquid and gas. The solid phase of water is called the ice. The liquid phase of water is called water, and the gaseous phase of water is called the water vapor. Now the solid phase or the ice is actually at the temperature 0 degree centigrade or below 0 degree centigrade. The liquid or water is in the range of temperature of room temperature, which is from 0 degree to 100 degree centigrade, and the gaseous phase is above 100 degree or at 100 degree centigrade when the liquid or water starts to boil and turns into gas. Now there is the processes which is involving the interchange of the states. First, if we are considering the solid will melt into the liquid. So melting is the process of conversion of the solid form of water into the liquid form on giving a particular temperature. Now the liquid form will turn into the gaseous form by the process of evaporation. So if we are just keeping a bucket full of water in sunlight, the upper portion of the water will start to evaporate by the heat of sunlight. Now the gaseous phase, when it is turned into the water vapor, it will again condense into the liquid phase. It will again get condensed into the liquid phase, and the condensed liquid might also get frozen into the solid state. Now the gaseous phase can also be reached without the liquid phase, or that is skipping the liquid phase, which is called sublimation. And deposition means whenever the gaseous phase, that is the water vapor, is turned into snowflakes and it is just falling, then it is called deposition. So we need to pay attention to the four processes, which are melting, vaporization or evaporation, condensation and freezing, and what are the changes of state that is taking place in these processes. As we have seen the three states of water and how the different processes are involved in the interchange of these three phases, it is actually represented by the water cycle. Water cycle is nothing but a cyclical process through which the different states of water keeps interchanging and they are cycled through a process which is called the water cycle. So circulation of water from the Earth's surface to the atmosphere and again from the atmosphere back to the Earth's surface is called the water cycle. So first, as we can see in the picture, there are the waters in the river or in the stream that is represented in the picture. Now the sun is in the sky, and from the sunlight the heat is actually on the upper surface of the river water or the stream water. So the liquid form of the river water will evaporate or vaporize into the atmosphere, and it will go up in the atmosphere as it is very light. Also, some of the trees are also expelling the excess amount of water in the atmosphere in the form of water vapor by the process of transpiration. So the water vapor is coming into the atmosphere by two processes. One is evaporation and one is transpiration. So together all of this water vapor is going up into the sky, and when in the upper portion of the sky, when temperature is that low, they will condense into the cloud. So they will turn from the water vapor form to the solid form. So they will condense. Now after the clouds have been condensed enough, they will when they are very heavy, they cannot hold the water vapor enough, so they will just fall off by the act of gravity on the surface of the earth in the form of precipitation or rain. So the precipitation or the rain will again come to the river water or pond water or lake water, and some of them will also go in the underground by seepage, and that will be stored there as underground water or surface runoff. And some of the snows will also melt from the glaciers, which will turn into the river water, that is, it will melt. So that is also called the snow melt runoff. So that is how the water is circulating from the earth's surface into the atmosphere as the water vapor by condensing, and then again when the water vapor will turn into the clouds and the clouds are getting very heavy, they will just come down by the work of gravity as the form of rain or precipitation, which will again fill up the water bodies of the earth's surface. So it balances the amount of water in nature and helps to regulate the water condition. Now we will see how the water acts as a solvent. But for that, first we need to know what a solvent is. So suppose I am taking a jar full of water and also a bowl full of salt. Now I am mixing the salt into the water jar and I am keeping it and keep stirring it, and then I am having a solution which is having salt and water. So that is what is a solution. Solution is a homogeneous mixture of two things or two or four components. Now in order to be a solution, it should be two components. One should be a little bit less in amount and one should be a little bit high in amount. So whatever is little bit less in amount is called the solute, and whatever is high in amount is called the solvent. So as we can see here in the salt water solution, the salt is less in amount and water is high in amount. So the water will be the solvent and salt will be the solute. So together the solute and the solvent will form a solution. If I am replacing the salt here with the sugar, then also the sugar will be the solute and water will be the solvent, and it will form a sugar water solution. But if I am adding a kerosene oil in the water, then the kerosene oil will not get mixed into the water, so it will form a heterogeneous mixture, but still it will form a solution because the kerosene oil will be immiscible and it will be forming a layer on the top part of the solution, and the lower portion will be just water. So here also, as the kerosene oil is lesser in amount, it is the solute and water is the solvent. So water actually can dissolve a lot of amounts of substances like solid substances, but it can also dissolve a lot of amount of gases as well, like hydrogen chloride, ammonia, etc. So water is actually called a universal solvent because a lot of things or lot of compounds, gases, liquids and solids get dissolved into water. So now if I am going to define what a solvent is the liquid portion in a solution in which the solute gets dissolved into. And solute is the solid substance which is getting dissolved in the solvent or the liquid. And together, when the solute and the solvent is dissolved together, is called the solution. In the right hand side picture, as we can see that the solute is a green colored powder and solvent is the water. And now the green colored powder has been mixed into the solvent, which is the water, and they have made a green colored solution. So here the green color powder is the solute as it is less in number, and water is the solvent. Can I dissolve any amount of salt in the jar of water that I have taken earlier? The answer is no, because every amount of liquid or every amount of solvent has a particular capacity up to which it can dissolve a particular solute. Okay, so see the left hand side tube, it is written as the unsaturated solution. So suppose it is already a solution which is having salt and water mixed into it. Now if I am adding more salts into the first tube, which is the unsaturated solution, those salts will get dissolved. So unsaturated solution is a solution into which if we are adding more solutes, the solutes will be dissolved into the solvent totally. But after keeping on dissolving the solute like this, a point will come when the solution will come into the second phase or the second tube where no more solutes will be dissolving. That is, even if you are just adding the salt, you will see that some of the salts are actually remaining at the bottom of the jar. So that solution is called a saturated solution. That means which solution can no more dissolve the solutes. The solutes will remain as a precipitate at the bottom of the jar. Now, even if we are still adding some of the solutes in the saturated solution, at a point of time, it will become a supersaturated solution where the added crystals will grow. There will be crystals of salt that will be growing at the bottom of the solution. But supersaturated solution is not in your syllabus. You just need to know about two types of solution: unsaturated solution and the saturated solution. Unsaturated solution is the solution which has capacity of more solute dissolving, and saturated solution is the solution which can no more dissolve any solute. So what is solubility? So solubility is the maximum amount of solute in grams that will saturate 100 grams of water at T degree Celsius. So it should be the maximum amount of solute that will be able to saturate 100 grams of water at particular temperature. That T degree centigrade temperature can be any temperature. So on the basis of temperature, the solubility will be different. Suppose if I am dissolving 50 grams of solute in 100 grams of water at 25 degrees centigrade, I will be able to dissolve more amounts of solute in 100 grams of water at 100 degrees centigrade, because the solubility of the solids increases with the temperature of water. So if I am increasing the temperature of water, it can actually dissolve more amounts of solutes. But the solubility of gases just follow the opposite trend. It decreases with the increase in temperature of water. So this is what solubility is.